Okay, number 5, we're still on drawing sine and cosine curves, but now we've got kind of a word problem, story problem to set us up. So, sorry, there's something on my screen. So, all right. First thing to do, read through the entire problem. Make sure you kind of get the idea of where we're going. Once you've read through the whole problem, though, whether it asks you to do this or not, I do recommend you sketch a graph. Now, this one in particular does ask you sketch a graph and find an equation. It does just say an equation. It doesn't say a sine or cosine particular. So we'll determine that after we've gotten the graph set up. So in our graph here, I'm going to move it over there best I can. The things to note says at one point, one place, highest average temperature 80 and the lowest is 60. So 80 and 60 are significant. Those are the temperatures that are the peak and the valley of our curve, whether it's sine or cosine. It also is saying it takes 20,000 years to go from a peak to a valley. So we kind of have this idea of time on the bottom, and then temp. Let's see if I can do that. Wow. Writing vertically is not easy. In fact, I'm not going to have room to do the numbers, so that was kind of a waste. Sorry about that. But what I want to point out though, like I'm going to mark the two values, 60 down here and 80 up here. So we have a peak and a valley. We will note then the 70 just for later reference. But what we're saying is, at one place, the highest average temperature is 80, and it takes 20,000 years to do that. So in the year 2000, so I'm going to mark, here's 2000. In the year 2000, the average temperature is at a high of 80 degrees. So that is a coordinate I can mark. 80 degrees in the year 2000. Now, it's going to take 20,000 years. So somewhere over here, that's going to be my absolute, that's 20,000 plus 2,000. And that's going to get us to our low value. So halfway in between, all right, is 12,000. We're at that 70 mark. So what this curve is supposed to it's implying that we have this sinusoidal curve that looks like that. That's all the information we're given. Now let's write a sine or cosine curve. Now, I'm going to tell you right now, I see a peak, but I don't see a midline that is increasing. I'm going to write this as a cosine curve. So I'm going to do a couple other things. I'm going to write out the characteristics, the properties, whatever you want to call them. I'm going to leave my final answer down here, f of t equals. Now my amplitude, if you look at the midline to a peak, midline to a valley, that's from 70 to 80 degrees or 70 to 60. So that amplitude is 10. My vertical shift, that's another pretty easy one. My vertical shift, well, here's my midline. My midline is 70 degrees. So my vertical shift is 70. Phase shift. Let's look at phase shift. Phase shift, my peak, we're saying in the year 2000 we have a peak, 80 degrees. So my phase shift is 2,000 years. Instead of the peak being at year 0, it's at the year 2000. The period is a little bit tricky because all they're giving us is the time it takes to go from a peak to a valley. That is not a full cycle. A full cycle would be from a peak to a peak or a valley to a valley. So over here, I'm going to call that period 40,000 years. So 2 pi over b, 40,000. So b, my period, I guess I should label that here. 40,000. So B is pi over 20,000. So as I write this, f of t is a, so amplitude 10. I'm writing this as a cosine curve of b, so pi over 20,000 times the quantity x minus c, the phase shift, x minus 2,000, quantity plus the vertical shift, 70. There you go. I can't stand that x got looking weird. But there you have it. Based on the graph, again, I highly recommend, even if they don't ask you to sketch the graph to get credit, you may as well. From there, we were able to identify those characteristics of amplitude, period, phase shift, and vertical shift. And then you just kind of write out the equation from there. So moving on, number 6, we got time. City averages 14 hours of daylight in June, 10 hours in December, 12 in both March and September. So, and we assume the number of hours varies sinusoidally. I'm pretty sure they made that word up, but we're going with it. So this one we're going to call, like, this is January, June, and December, where that is March and September. Okay, perfect. So active times, city averages 14 hours in June. So here's June. We have that peak of 14. There it is. They have 14 in June, 10 in December. So I know my valley down here is 10. And there it is. Then it says 12 in March and September. So my midline here, 12 in March, September, and January. Oh, what does this say? Oh, it doesn't say anything. Okay, well, December to January, we're going to mark that as kind of that same point on the curve there. So what we have is up and down. Okay, sorry, it's the best I could do. Again, in a graph like that, I recommend doing the properties. If you want to also write out the A, the B, the C, and the D, that's also fine. But here we've got this midline. You know what, I'll even draw it. There's our midline, beautifully drawn. Sorry about that. But that is at 12 hours, and we go to a maximum of 14 hours in the summer and a minimum 10 hours in the winter. So the amplitude from 12 to 14 or 12 to 10, that is an amplitude of 2. Our phase shift and vertical shift, well, the vertical shift is 12. And the reason, again, is your midline is 12 hours. So that's your vertical shift. Honestly, you guys, this one, let's check. It says sketch a graph. Okay, so sketch a graph, we did do that. We got that down. And this says find an equation that models a number. Okay, so again, we are going to note that we don't have to specifically do sine or specifically do cosine. But, gosh, you know, I'm going to say period equals, well, what's the period of this? I'm going to use the units of months, so 12 months. 2 pi over b is 12. B is equal to pi over 6. The period, though, again, that was 12 months. The phase shift. Well, honestly, you guys, it really isn't going to matter. Let's do both. So f of t is 2 times sine pi over 6 x minus, if I'm doing sine, that's that midline increasing. So there's the midline where it's increasing. That's at March. March is 3 months in, so x minus 3 vertical shift was 12 hours of daylight, so plus 12. So that was one answer. And if you were happy with that, by all means, that's what you want to do. If you wanted to do cosine, remember the only thing that's changing, not the amplitude. Amplitude's still there. Pi over 6, still the same. Our period hasn't changed. X minus some number. That's also a vertical shift of 12. But here cosine is peaked in June. June is halfway through, so x minus 6 would be your other answer. So again, feel free to use either of them. It does not say to choose both of them. I just wanted to show you that that's possible in that one. So that ends 3-2 and graphing trig functions. So I'll stop there. Next video, we'll start question 7, lesson 3.3.